Lesson 14.1, Task 3. Write recursive formulas for arithmetic sequences. Write a recursive formula for the sequence shown in the table. So you can see they give us the first 6 terms. So this is terms 1 through 6. And the first term is 27, and then 23, 19, and so on. So you can see that it goes down by 4 each time. So our common difference will be -4. So it says there is a common difference of -4, so we know the sequence is arithmetic. Using function notation, you can write a recursive formula for the sequence as a of 1, your first term, equals 27, and then a of n equals a times n minus 1, this is your previous term, minus 4. All right, it says how can you use the recursive formula to find the 7th term? Well, you would simply plug 7 in for n and then solve. All right, so it says place the steps correctly to show how to use a recursive formula to find the 7th term. All right, so we take the formula, we plug in 7. So we've got a of 7 minus 1 in parentheses minus 4. So we have to evaluate what's in parentheses first. So that's going to be a of 6. Okay, a of 6 means your 6th term. If we look at the table, our 6th term is 7. All right, so we're going to have 7 minus 4. And 7 minus 4 simplified is 3. All right, it says how can you write the recursive formula in subscript notation? Remember, subscript notation is similar to function notation, but it just has the number set kind of below. So this would be function notation, and this would be subscript notation. Now, what's the difference between these two? Well, the second part of these are the same, except it looks like these are set up further than they should be. But the difference is this says the first term is 27, and this says the nth term is 27. So we know that we have to have the first term. So it would be, subscript notation would be the third one there. All right, that's all for task 3. If you have any questions, please let me know. Lesson 14.1, task 4. Write recursive formulas for an arithmetic sequence. Write a recursive formula for the arithmetic sequence with terms a sub 5 equals 10 and a sub 22 equals 61. So they're giving us our 5th term and our 22nd term. It says find the common difference d. So we can subtract 22 minus 5, and we know that there are 17 terms in between our 5th term and our 22nd term. So it follows that our 5th term plus 17d, 17 times our common difference, equals our 22nd term. Now, all you have to do is substitute what you know. We know our 5th term is 10, and we know that our 22nd term is 61. That leaves us with only one variable, d. So this way we can find our common difference. So subtract 10 from both sides to get 51, and then 51 divided by 17 equals 3. So we quickly found our common difference using 2 terms that were given. Okay, so it says, why can you find a sub 22 by adding 17d as to a sub 5? So how can we get this term? By adding our common difference 17 times from a sub 5. Since a sub 22 is 17 terms after a sub 5, so a sub 22 is 17 terms after a sub 5, you need to add 17 times your common difference, which we found is 3 now. But we need to do 17 times our common difference to a sub 5 in order to find a of 22. To go from one term of the sequence to the next term, you add the common difference. And you do that for any arithmetic sequence. All right, it says find the first term, a sub 1. All right, so we have the 5th term, okay? The 5th term is 10, so we already know the 5th term. And so we can substitute 10 in here, and we just found the common difference above for 3. So since 5 minus 1, so we know our fifth term down to our first term is 4 terms away. So we can do our first term plus 4 times our common difference equals 10. And again, 10 was given above. 3 is our common difference. And 4 came from subtracting 1 from 5 to find the first term from the fifth term. So if we subtract 12 from both sides, 10 minus 12 is negative 2. All right, why do you need to find a sub 1 in addition to the common difference? Well, anytime you're finding a recursive formula, you need to have your first term as well. So let's see what they say here. Knowing the common difference D lets you write the recursive equation, but the full recursive formula for an arithmetic sequence also requires specifically the first term of the sequence. Therefore, a recursive formula for the sequence a sub 1 equals negative 22, so your first term is negative 22, and a sub n equals a sub n minus 1 plus 3, or the common difference. All right, that's all for task 4. If you have any questions, let me know. Lesson 14.1, task 5. Translate between formulas for arithmetic sequences. Given an explicit formula for an arithmetic sequence, you can write a recursive formula and vice versa. The table below shows how to translate between these two representations of an arithmetic sequence. All right, so this is something that you definitely need to have in your notes. So we've got function notation and subscript notation for both the explicit and the recursive formula. Okay, so you can see how they're similar and how they're a little different. All right, I would pause the video and write this down and then continue when you're finished. All right, write an explicit formula for the arithmetic sequence defined by the recursive formula. A sub 1 equals 2, so our first term is 2, and a sub n equals a sub n minus 1 minus 7. So this shows that our common difference is negative 7. So the first term of the sequence is 2, and the common difference is negative 7. Substitute these values into the general formula of the explicit formula for an arithmetic sequence. So our general formula is a sub n equals a sub 1 plus n minus 1 times d. All right, so if we substitute our first term of 2, which is given, and our common difference of negative 7, which is given, then we can simplify this expression. So you need to distribute the negative 7. So you're going to do negative 7 times n is negative 7n. Negative 7 times negative 1 is plus 7. Negative times a negative makes that a plus there. Then you can combine like terms. Your 2 and your 7 do not have a variable, so you can combine those and get 9. All right, and then just bring down your negative 7n. All right, not sure why they have an extra step here of the exact same thing, but you do need to combine the 2 and the 7 to get 9, bring down your negative 7n, and that's how you rewrite the formula as an explicit formula. So it says an explicit formula for the sequence is a sub n equals 9 minus 7n. So this is an equivalent formula to this, it's just in the different form. All right, so it says, how do you know that the common difference of the sequence is negative 7 instead of 7? All right, so we know that it's plus n minus 1 times d. So the recursive equation for an arithmetic sequence has the form a sub n equals a sub n minus 1 plus d, our common difference. Since the given recursive equation is a sub n equals a sub n minus 7, it must be true that d is negative 7. So that's just basically telling you to be careful with your signs. All right, it says, Kilm says that because the first term of the sequence is 2, the explicit formula should be a sub n equals 2 minus 7n, and why is Kilm mistaken? All right, so the first term corresponds to n equals 1. That's your first term. Kim's formula gives a first term of a sub 1 plus 2 minus 7 times 1. Substitute 1 in for n, which equals, so it'd be negative 7 plus 2, so that equals negative 5. And this is incorrect because we do know that our first term is 2. All right, that's all for task 5. If you have any questions, let me know.